Hello dear students, welcome you to transmission and distribution class. So in the previous class we have seen some problems on the unequal level supports sag calculation. Today also we will continue with the problem with the gradient one. Okay, so let us see one example 8.26 where problem is given as transmission line over a hillside where the gradient is 1:20 is supported by two 22-meter high towers with a distance of 300 meters between them. The lowest conductor is fixed 2 meters below the top of each tower. Find the clearance of the conductor from the ground given that conductor weighs 1 kg per meter and allowable tension is 1500 kg. So let us solve the problem. Okay, see here the conductors are supported between the towers AD and BE as seen in your figure. You can see AD and BE are the two towers with a gradient of 1:20 ground. So you can see gradient means what? Um, you can see here 1:20. Here the sine theta is 1/20. That is what the gradient. Okay, means this theta where theta means what? Sine theta means it is opposite side by hypotenuse. Okay, so if the EC means the height of the hill from the point D is 1 meter, means the vertical horizontal distance is somewhat 20 meter, means from the ground here to you are moving to some 20 meter, means from the where you started, no, that you and the where you reached, that point is 1 meter height from the point where you started. Understood? Means if you are starting from one point, it is in downwards. If you are moving in a hill for a 20 meters, means at that particular point you are at the height of 1 meter. Okay, fine. Now they are given that 2 meters below the conductors are tied. Then effective height is 22 minus 22 meter height 2 meters below, so 20 meters effective height. The vertical distance between the tower is given by h is equal to h is the vertical distance, is what? EC. See, EC is nothing but what? D sine theta. So we need to calculate what is the h here. Okay, EC is D sine theta, where already span is given, that is what your D is given by 300 meter. So 1:20, 15 meters. Okay, so and here you can find clearly, if you are moved for a 300 meters, you will find a height of 15 meters. Fine, same as I told you. If you move for a 20 meter, you will get a 1 meter height. Same thing here. You are moved for 300 meter, you will get a height of 20 meter, no, 15 meter. Fine. So DC is calculated by D square by EC square. If you have calculated approximately 300 meters only you are getting, because the height is very less compared to the length. Okay. So x1 plus x2 is given by 300 meters span. So you are knowing h is equal to s2 minus s1. You are simplifying this one. So anyhow x1 plus x2 is 300 meter. All w you are knowing, tension is given. So if you are going for x2 minus x1, you will get 150 meter. So by solving x1 and x2, you are getting x1 is 75 meter and x2 is 225 meter. So if you calculate s2, you are getting 16.87 meter. BC, BC is what? Total height from the second tower to the ground is what? B plus EC, that is 20 plus 15, 35 meters. Now clearance from the lowest point O from the ground is given by HF. HF is what? Total height from the B to ground. Okay, minus S2. S2 is the sag from the highest point to lowest point of the second tower. Okay, fine. Then minus GF. GF is what? GF is the you can see in the height which is under the ground. Okay, so here HF is nothing but it is same as BC. S2 is as it is minus GF. So we are getting here 14.38 meters. This is the clearance from the lowest point to the ground is 14.38 meters. It is not as the 16.87 meter, because 16.87 meter is the S2. Okay, from the highest point, and from ground clearance we will calculate till F, and but G and F is under the ground, so we need to calculate OG. Fine. The same type of problem is given here. You can see a transmission tower on a level ground is gives a minimum clearance of 8 meters from its lowest conductor with a sag of 10 meter for a span of 300 meter. If the same tower is to be used for a slope of 1 in 15, same as that gradient is 1 is to 20 you are seen in the previous problem. No, in this problem it is 1 is to 15. And find the minimum clearance obtained from the same span, same conductor and same weather condition. Fine. On level ground, if it is there, S is equal to W L square by 80. W by T is equal to 8S by L square, and we are calculated. Okay, because we are given that sag is given here in the problem. Minimum clearance is 10 meter is given, so we can calculate here 8 into S by L square. L is 300 here, span is span, and sag is 10 meter is given, so we will calculate W by T is 8 by 9 into 10 raised to 3. Height of the tower is nothing but what? Sag plus clearance, that is 10 plus 8, 18 meter is the sag. So we calculated now height of the tower, and W by T we got it because we don't know what is W and T, but it's a ratio of W by T is unknown. Anyhow, it can be put in the equations. Fine. Now sloping ground. If this previous conditions what you calculated is only for same ground. Now level ground, that is now it is on sloping ground as the previous problem, that is 1 is to 15. Same H we need to calculate. Sin theta is 1 by 15, 20 meters you will get. X1 plus x2 is 300. Once again same procedure. X is equal to, now x2 minus x1, fine, we will calculate. X1 is 75, x2 is 225. S1 and S2 is calculated. S1 is 2.5 meter, S2 is 22.5 meter. Same clearance from the point O is calculated as 10.5 meter. All these things we solved in the previous problem. Now the origin is O. Equation of the slope is given by y is equal to mx plus a, where m is equal to 1 by 15, that is the slope. A is nothing but OG. OG, that is minus 10.5. Then C is the clearance from the point X. So C is given by equation of the conductor curve minus y. So wx square by 2t minus x by 15 minus 10.5. So you put the values of w by t, as you know x you are knowing. So x is the unknown thing here. You will get the C. Then you will derivate and equating it to 0. So you will get x as 75 meter. Then putting these values for the minimum clearance equation, you will get the 8 meter as the minimum clearance. So once again you solve this problem by your own, you will come to know how to solve the things. Now some mechanical principles we will see. So important points to be taken while mechanical design of the overhead transmission line. First one is the tower height. Tower height depends upon the length of the span. Okay, with long spans, relatively few towers are required, but they must be tall and correspondingly costly. If it is tall, means obviously it is costly. It is not usually possible to determine the tower height and the span length on the basis of the direct construction cost, because the lightning hazards increases greatly as the height of the conductors above the ground is increased. This is one reason the horizontal spacing is favored in spite of the wider right of way required. Okay, so one point is clear: if tower height is increases, means obviously cost is increases. Conductor clearance to ground. So this point is what? The conductor clearance to ground at the time of the greatest sag should not be less than some specified distances. Okay, depending on the voltage, the nature of the country, on the local laws, this is determined. The greatest sag may occur in the hottest day of summer on account of the expansion of the wire, and or it may occur in winter due to the coating of ice. So special provision must be made for the melting of ice in the power line. So this is the conductor's clearance to ground. We need to take care in summer season in our very hot areas because of expansion. In winter, in the some areas like snow falling, the coating of the ice. So all these things. Sag and tension. When laying the overhead transmission line, it is necessary to allow a reliable factor for safety in respect of the tension to which the conductor is subjected. The tension is governed by effects of wind, ice loading, and temperature variation. The relationship between the tension and sag is dependent on the loading condition and the temperature variations. For example, the tension increases when the temperature decreases. There is a corresponding decrease in the sag. Icing up the line and wind loading will cause the stretching of the conductor by an amount dependent on the line tension. So, in planning the sag, tension and clearance to the ground is for a given span, the maximum stress is selected. It is the aim to this stress developed at the worst probable weather conditions. When loading increases the sag in the direction of resultant loading but decreases the vertical component. Therefore, in clearance calculation, the effect of the wind should not be included unless horizontal clearance is important. Okay, so this is regarding the sag and tension. Stringing chart. Stringing chart is very simple. For the use of the field work, we are making a chart. This is sag and tensions variation with respect to temperature. So the figure 8.33, you can see the stringing chart. This will helpful while erecting the overhead lines. Conductor spacing. Conductor spacing is should be such so as to provide the safety against the flashover when the wires are swinging due to the wind. The proper spacing as a function of the span length, voltage and weather conditions. The use of horizontal spacing eliminates the danger caused by the unequal ice loading. Small wires or wires of light material are subjected to more swinging in the wind than the heavy conductors. Therefore, the light wires should be given greater spacing, because we know if it is weight is very lighter, because of wind it is having a higher swing. That's what it is to be taken very care. Then conductor vibration. Wind exerts pressures on the exposed surface of the conductor. If the wind velocity is small, the swinging of the conductor is harmless. If wind velocity is high, then the hanging or swinging of the conductor is more. Due to this, it will give the a different vibration to the conductor. It is called dancing. Is caused by the action of fairly strong wind on the wire covered with the ice. When the ice coating happens to take from, which makes a good airfoil section, then the whole span may sail up like a kite until it reaches to limit of its slack, stops it with a jerk and falls off, sails back. So harmful effects of these vibrations occurs at the clamp or supports where the conductor suffers fatigue and breaks eventually. So in order to protect the conductor, dampers are used. So these dampers are to avoid the vibrations in the conductor. So these are some mechanical principles or mechanical things need to be taken care while designing the overhead transmission line. In the next class, we will see the how insulators are used and what are the requirement of insulators and different calculations in that insulator unit. Thank you.